What's up, guys? Welcome back to my YouTube channel. And for today's vid, I will be doing the activities in chapter 7. So if you want to learn something from me, or if you want to get some information about the chapter 7, so stay tuned, and please like and hit the subscription button. I will be back, guys. Guys, so welcome to my video in chapter 7. So for our first video in chapter 7, our first activity entitled Binary to Decimal Conversion Activity. So the instructions is this activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We recommend that you work with this tool until you are able to do the conversion without error. Convert the binary number shown in the octal to its decimal value. So, in our first activity, we will be doing the binary to decimal conversion activity. So, there's the binary number, the 1101010110. And the decimal value, we will be putting the decimal value over there in the blank space. So if we the base is the 2, then the exponent is the 7, 6, 5, 4, 3, 2, 1, then 0. Then the position is 1, 2, 4, 8, 16, 32, 64, and 128. So as we get the decimal value, we can see here that there's number 1 and number 0 in the bit. So all of the column or all of the rows that have number 1, we will be adding it or we will be summing it. So the first one is the number 2. So number 2, then the second one is the 4, so plus 4, 2 plus 4. Then the next one is 16 plus 16. Then the next one is 64. Then the last one is 128. Again, the 2, then the 4, then 16, then after the 16 is 64, then the 128, so equals 214. So we will put here the number 214. So let's see if it is correct. And it's correct. So the decimal value you have entered is correct. So please click new to number 2. Continue. So if you want to the next number, we will be clicking or pointing here in the new numbers. So for another set or another table. So that is our first activity in chapter 7. Okay, so for our second activity, it is decimal to binary conversion activity. So the instructions is this activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work with this tool until you are able to do the conversion without error. So convert the decimal number shown in the decimal value, rotates binary bit. So it's like the activity in our first activity, but it is the binary to decimal, and here in our second activity, it is the decimal to binary. So the decimal value is given at number 52. So we will be finding the binary or the bit. So again, our base is 2, then the exponent is 0 to 7, then the position is 1, 2, 4, 8, 16, 32, 64, and 128. So we will be putting in here in the bit the 0 and the 1. So we will put 0 if we think that the number is wrong or it is not sum up with 52. But we will be putting a 1 or number 1 if it is equals, if we add it and it will be equaled by 52. Then let's see. So 128 is a big number. Well, I think it is 0. Then the 64 is 0. Oh. Then the 64 is 0. But in the 32, there is a chance to plus or to add to another number that equal to 52. So let's put number 1 in 32. Then 16, we can plus 32 and 16 because 32 plus 16 equals 48. So we're putting 1. Then the 8, it cannot add because it will be not equal by 52. So let's put 0. And the 4, let's put number 1 because 32 plus 16 plus 4 is 52. So the given is number 52. So if we plus 32 plus 16 and 4, it's equal to 52. So that is our answers, and remaining is put 0. We put 0, then 0. So let's see if it is correct. So it's correct. So the binary values you have entered for all positions are correct. So again, if we want to the new table, we click the new number. But if we are satisfied here, or we learn something in this first table, so we can jump into the next activity. Okay, so for our next activity, the ANDing to determining the network address. So the instructions is use the ANDing process to determine the network address in binary and decimal format. So here in our activity, we will be only using 1 and zeros, but in the network address in decimal, we will be put the final answer. So in host address in binary and subnet mask in binary, as you can see, there are zeros and number ones. And in the 1, 2, 3, 4, 5, 6, 7, in 8 digits, we will find the both numbers 1 and number 1. If there's number 1 in subnet mask in binary and in network address, host address in binary, so we will be matching it if it is same as number 1. So if it is 0 and 1, it is equal to 0. 1 is 0, it is 0. But 1 and 1 is equals to 1. So let's see. So here in network address in binary, so there are 0, 0 in host address in binary. So 0, 0, 0, 4 zeros, then 1, 0, 1, 0. And under that host address in subnet mask, there are 1, 1, 1, 8 digit of 1. So 0 and 1 is equals to 0. So same as 3 digits. Then 1 and 1 is equals to 1. Then 0, 1 is equals to 0. Then 1 and 1 is equals to 1. Then 0. Then the next one, 0 and 1 is equals to 0. Then 1 and 1 is equals to 1. So 0, 1, 0, 1. So 0, 0. Then 1, 1. So 1. Then 0. Then 1, 1. And next, so 1 and 1 is equals to 1. Then 0, 1 is 0. Then 1, 1, 1, 1. Then 0, 1 is equals to 0. 0, 1 is equal to 0. And 1 and 1 is equals to 1. Then 0, 1 is equals to 0. So for our last 1 and 1, then 0, 1 is equals to 0. 0, 1 is equals to 0. Then 1 is equals to 1 and 1 is equals to 1. Then all remaining 3 digits is 1, 0, 1, 0, 1, 0. So it's equals to 0, 0, 0. And for our network address in decimal, so we will be finding the network address in decimal. So we will be putting the number 10. So 10, then 75, then 178, and last one is 207. So let's see if it's correct. Oh, it's incorrect. In our last column or rows, it is the 1 1. So it is 128. That is 128 plus 64, then plus 8. So equals 200. So let's put 200. And let's see. And it's correct. So how, if you want to know how I find that 10, 75, 178, and 200, all that number 1 in network address and binary, they're equivalent in or do you remember the 1, the 2, the 4, the 8, the 16, the 32, the 64, and 128? So you will be adding that number 1 or the equivalent numbers in that equivalent numbers. So we will be adding that, and the equals is in the network address in decimal. Okay, so for our next activity, the unicast, broadcast, or the multicast. So the instruction is click start to view the destination IP address. So if we click the start button, there are will be appearing a destination IP address. Then next is click the hosts or these computers which will receive a packet based on the address type, unicast, broadcast, or multicast. This is a timed activity. So there are numbers or there are IP address that will be appearing here in our upper corner of the screen. So if there are numbers or the IP address, we will be finding the host or the computers of which will be receiving a packet based on the address type. It is unicast, broadcast, or multicast. So this is a time activity. So there are time only 10 seconds, and we'll be starting now. So let's click the start button. The timer starts now. Then the 192.168.1002. So we'll be finding the 192 or the 168, the 1002. So that's it. And let's see. So you have successfully identified the transmission type. So the IP address is the 192.168.100.2. So the source or the so again, next one is 225.5.7126. It is, yeah. So you have not successfully. So it is wrong, I guess. So this is the right answer. Okay, for our next activity, it is entitled the pass or block IPv4 address. So the instructions, decide to pass or block each IP address depending on whether it is public, the internet, or private, small local network. Then click start to begin and click on either pass or block. So there are two choices, the pass and the block. So there are some will be appearing some IP addresses. Then we will be click if it is pass or block. So let's start. We will be clicking the block button. The block button if it is starting from 10 or the 172.16 and the 192.168. So let's start. So 131 is pass. Then the 215 is pass. Then the 132 is pass also. Then the next one is 108 is pass. Then the 199 is also pass because it starts with 999. And we have already got 10 points. So let's see again. Let's reset. So let's start. The 10 is block. It starts with 10. Then the 132 is pass because it starts with 132. Then 172 is pass. Oh, it's wrong. So minusing 127 is pass. Then the 172 is block, which starts with 172. Then 192 is pass. Oh, it's block. Then 45 is pass. Oh, then 88 is pass. Then the 141 is pass. And yeah, that's all. So I hope you guys understand the IPv4 address or the activity of pass or block the IPv4 address. Okay guys, for our next activity entitled public or private IPv4 address. So guys, it is raining and I hope the quality of the audio is good. It is raining very loud and the water is coming flow from the roofs, and I think it is heard from the audio. So I hope you guys just sorry for the audio. So our next activity is public or private IPv4 address. So the instruction is drag each IP address to the correct category, public or private. So we will be putting some IP addresses here in the public, or it is a private. So in 172 and the 172, the tens and the 172, the 10 and the 192. If it starts with the 172 and 192 and 10, it is private. So let's try 172.16.35.2. It is private. But and the 192.168 is also a private, and the 192, but in 192 it is followed by 168. So it is not followed by 168, so it is a public. Then the 64 also in public, the 209 is in public, the 192 and the 168 is in the private, then the 172.16 is private, then the 1055 is in private too. So let's see if it is correct. So it's correct. So as you can see in the private, the IP address starts with the 172.16, then the 192.168, and the 10.55. So that we can know if it is private or public. Okay, for our next activity entitled the IPv4 issues and solutions. So drag the IPv4 and IPv6 terms to the field next to the appropriate description. So the description is the 128-bit address, 340 and decillion addresses. The next one is the 32-bit address, the 4.3 billion addresses. Then it transports an IPv6 packet over IPv4 networks. Then the next one is the uses an 8064 to convert between IPv6 and IPv4. And the last one is allows IPv4 and IPv6 to coexist on the same network segment. So we'll be dragging these terms to this description. So the first description is the 128-bit address, or the 340 and decillion addresses. That is the IPv6. Then the next one is the 32-bit address, so 4.3 billion addresses. It is the IPv4. Then transports an IPv6 packet over IPv4 network, so it is tunneling. Then the next one is uses an 8064 to convert between IPv6 and IPv4, so it is translation. Then the last one is allows IPv4 and IPv6 to coexist on the same network segment, so it is the dual stack. So let's see if it's correct, and it's correct. So that is the terms and the description of the IPv4 issues and solutions. Okay guys, so for our next activity in the practicing IPv6 address representation, so instruction is convert the IPv6 addresses into short, omit the leading zeros, and compress forms. Use the numbers at the bottom of the page to continue this activity. So for our first figure, the IPv6 conversion, so preferred format, so there's numbers, then the omitted leading zero is blank, and the compressed format. And we will be doing this activity. So we will be typing the 2, then the 001. Then the next one, we can see the preferred format is 0. So we will be putting only 1, 0. Then in the next one is it starts with 0. So we cannot, or we can not include that 0 if the 0 is in the first number. So we can also we can put the D, B, and the number 8. So in the next one is the number 1 for 1, 1, 2, 3, 4. Then also 0 because it is 0 value. Then the next one is 0. Then the next one is 0 again. Then the last one is, we can see that the first number is 0, so we can not put there, or we cannot put, or we cannot put 0 if it is 0 in the first number, so we can put 200 also only. So for our next the compressed format, so we will be typing so for our compressed format, we can see the element leading zeros. We will type the 2001, so we will put a colon, then 0, then again colon, then the DB8, then again colon, then the 111. So we can see there are 3 zeros, so we will be compressing it, and we will be putting 2 colons, then the next one is the 200. So let's see if it is correct. And yeah, it's correct. So if there are many zeros, we can put only the two colons to compress the format, or to compress that omit leading zeros. Okay, for our last activity in Chapter 7, guys, the activity is titled by Identify Types of IPv6 Addresses. So, the instruction is drag the IPv6 address type to the most appropriate description. So, there are the global unicast, the link local, and the 64. So, the first one is unique internet routable IPv6 address, or the dynamic or static. It is the global. Okay guys, so the first one is the unique internet routable IPv6 address, or the dynamic or static. So it is the global unicast. The next one is the FE8011, so it is the link local. So the next one is the 2001 DB8 ACAD164. It is the global unicast also. Then the typical IPv6 prefix used to indicate the network portion of the address. It is the 64. Then the last one is used to communicate with other devices on the same IPv6 subnet. It is the link local. So let's see if it is correct. And it's correct. So guys, that's all for this vid. I hope you get some informations and you learn something from me about the chapter 7. And for my next vid, I will be doing the activities of chapter 8 and chapter 9. So, stay tuned, and please hit the subscribe or the subscription button for more videos to come. Thank you guys!